Good afternoon. Thank you for joining us today for our Safer Sim webinar. The presentation features research from the University of Central Florida. Please use the chat box in your lower right corner of Adobe Connect for any questions or comments. We will have time at the end of the presentation to address those. So now I'm pleased to welcome our presenter today, Hasibur Rahman, PhD student from the University of Central Florida.
Hello everyone. Good afternoon. My name is MD Hasibur Rahman, PhD student of University of Central Florida. Today I'm going to present an interesting study named School Zone Safety and Effective Countermeasures, a micro-traffic simulation study. Before going to the main slides, I would like to thank Dr. Lee, PI, and Dr. Ati, co-PI of this project for the continuous support to complete the project successfully. Crashes occurring in school zone have been considered as a serious public health concern in US. Many previous studies evaluated the effectiveness of various traffic control devices, for example signs, marking, reduced speed limit with flashing beacon, dynamic speed monitoring display, speed monitoring signs in the school zone area. There is a very few study evaluated the safety effectiveness of roadway geometry in the school zone area. So the objective of this study is to evaluate crash risk in a school zone with a certain speed limit reduction and propose a solution, and investigate the effect of median type and the number of driveways on safety in school zone and suggest countermeasures. Study area. In order to identify the most crash-prone school zone in Orange and Seminole counties in Florida, we used school location data, annual average daily traffic, total crashes for the year of 2012 to 2016. By creating a buffer around the school zone, we analyze the crash rate, which is defined as total crash per 1,000 daily vehicle miles traveled. Here I am showing the top 10 schools based on the crash rate in Orange and Seminole counties in Florida. And in this study, we use the top 2 schools as our study area since they are very close to each other. The red box showing the top 2 schools that we are going to study in our study. For microsimulation network, existing traffic volume data was collected near the school zone via volume study survey during weekdays, morning and afternoon school peak period. 3 types of vehicle compositions were counted separately, for example, passenger car, heavy vehicles, school buses in this survey, and their percentages were 95%, 3%, and 2% respectively. We developed a network in VSIM that was 3.21 mile long on West Oak Ridge Road, that is the main road near the school zone area, and which is connected with other main road, that is South Johnny and Parkway. And in our microsimulation, we used 1.7 mile of this road. 19 driveway access and 7 intersections were included in the network. In order to input the traffic volume for each roadway in VSIM, we used traffic volume percentages with respect to AADT, which was found from the volume study survey. Speed and travel time data was collected from here and National Performance Measure Research Dataset. Different speed distribution was used for different vehicle types depending on the locations. The figure shows an example of the speed distribution that is used in the VSIM environment. So this is the figure that is showing the whole microsimulation network that was built in the VSIM environment. And here we can see the 2 school zone, the black and the blue colors, and the 2 major roadways and the other driveways that is used in our study. For calibration and validation of this microsimulation, we aggregate the traffic volume data into 5 minutes interval, and we used 3 statistical parameters. First one is GEH statistics, which is similar to chi-square test, but it is an empirical formula which compares 2 sets of traffic volume, which is field and simulation. GEH value should be less than 5 for 85% cases in order for good calibration. Another one is correlation coefficient, which measures the correlation between field and simulation data. The value of correlation coefficient close to 1 means good correlation. Last one is the Thales inequality coefficient, and the lower value of this parameter is to be expected. This is the result of the calibration in our study, and we found that more than 89% of the cases the GH value were less than 5, and around 99% of the cases GH value were less than 10. The correlation coefficient value is 0.96, which indicates a perfect and direct correlation. Thales inequality coefficient was found 0.08, which means the error is very small and there is a perfect fit between the simulated and observed volume. For validation, we use travel time. The validation criteria is if the observed travel time is less than 7 minutes, then the observed and simulation travel time should be within plus minus 1 minute. Otherwise, it should be within plus minus 15% for 85% cases. In our study, we found around 100% cases the simulated travel time and the field travel time difference were less than 1 minute, and around 87.5% cases the difference between observed and simulated travel time were less than 15%, which meet the stated criteria. So in order to assess the safety performance of different roadway characteristics in school zone, we developed 3 countermeasures, which is two-step speed reduction, decreasing the number of driveways, and replacing two-way left-hand lane with race median. Now I'm going to explain all of these one by one. In two-step speed reduction, I'm explaining the whole thing in this figure. In the first part of the figure, I'm showing the conventional reduction of speed in the school zone. Here we see the upstream speed, vehicle speed is very high, which merge with the downstream low speed vehicle, and there could be a possible risk for the crash. So in order to avoid this, we provide an intermediate zone for the speed reduction, and the second part of the figure showing how it works in the simulation. In this study, we tested 3 scenarios in two-step speed reduction, which we called sub-scenarios. The first one is 40, 20, 15. I'm explaining what does it mean. The 40, 20, 15 means the upstream speed is 40 miles per hour, intermediate speed is 20 miles per hour, and the school zone speed is 15 miles per hour. The other 2 sub scenarios are 40, 25, 15, and last one is 40, 30, and 15. In the decreasing the number of driveways. In the study area, driveway density is very high, which might create the crash frequency near the school zone area. So in this method, we directed the vehicle that are coming from driveways to use the collector road instead of direct access to the main road. Here I'm showing the figure how the collector road and the collector road are helping the driveways to connect with the main road. Also here I'm showing the videos how it works in the simulation environment for our analysis. So in this method we used 4 sub scenarios which indicates the different reduction percentage of driveway density. First we tried 25% reduction of the driveway density, and then 50%, 75%, and last one is 100%. Replacing to a left-hand lane with race median. In the study area, to a left-hand lane is present, which might create confusion to the drivers during turning movements and result in severe crashes. So we replace the to a left-hand lane with race median and evaluate the safety. 2 sub scenarios was developed here. One is median U-turn and intersection U-turn, so that the vehicle could move their desired destination. Since the simulation cannot directly measure the crashes, so we use 3 surrogate safety measures, where 2 of them are developed from time to collisions. The 3 surrogate safety measures are time exposed time to collision, that is TET, time integrated time to collision, that is TIT, and time exposed rear end crash risk index, which is TERCRI. In this figure, I'm showing the percentage change of these 3 surrogate safety measures, that is TET, TIT, and TRCRI with respect to the base scenario. Positive percentage means the lower value of TET, TIT, and TRCRI. So we see that all the scenarios in two-step speed reduction and decreasing driveway access improve safety as the value of TET, TIT, and TRCRI is get reduced. Also, the combination of these two methods outperform than others, but the surrogate safety measures value is higher for median and intersection U-turn. We also did ANOVA test for the three surrogate safety measures and found that they are significantly different from each other for all the scenarios that I mentioned in my previous slide. We evaluated the sensitivity analysis for different value of TTC threshold that is ranging from 1 to 3 seconds and found that it doesn't affect the result. Here I am showing the sensitivity analysis for three sub scenarios with respect to the base for three different value of TTC threshold, and all the scenarios we found that there is a improvement for all of these scenarios. In this figure, I am showing the distribution of TET, TIT, and TRCRI for the base three sub-scenarios, which clearly showing the improvement of the crash risk. So finally, the result indicated that the implementation of two-step speed reduction and driveway reduction significantly improved safety in exclusion area. The value of TET, TIT, and TRCRI were larger for base scenario than all other sub-scenarios except converting to a left-hand lane to race median. Into a left-hand lane to race median, two sub-scenarios were tested and showed a larger value of surrogate safety measures than the base scenario because the large amount of traffic that made U-turn both at the intersection and median. The combined scenario of two-step speed reduction and driveway reduction performed the best. One-way ANOVA showed that there was a significant difference among all 13 sub-scenarios, and finally we found that the sensitivity analysis indicated that the different value of TTC threshold do not affect the results. Thank you everyone. Any questions?
Thank you for the presentation, Hasibur. We do have time for any questions or comments, so there is a chat box in the right-hand corner. If anyone has any thoughts, please feel free to go ahead and share them. So it does look like we have someone typing in a question. While we're waiting for that, I would like to invite everyone that attended today to keep an eye out for our next webinar. That presentation will be featuring a research project from the University of Massachusetts Amherst, and that will be on March 26th. So it's a month away. We will be taking a week off in between, but keep an eye out for the flyer. Okay, so we have a question here. It seems a method of reducing the potential conflicts by reducing accessibility. What measurement do you have to weight those two aspects?
So for the measurement we provide driveway access reduction like 25% or I mean with different percentage deduction. So I'm not sure what he or she is asking. So there will be two aspect of accessibility, like accessibility or the conflict. And in our study, we control the accessibility and improve and see how it improves the for reducing the conflict. So is that the questions?
So they continued, under what scenarios should your proposed method be implemented?
So In our study, we found that there is a lot of driveway access in the study area. So when a school is situated in an area where there are a lot of driveway access or in the residential area, then our study would be implemented better.
Excellent. Well, thank you everyone for attending, and we will see you next time.
Thank you everyone. Have a good day.